Hi, I'm Alex from the Zscaler Customer Success Engineering team. In this series of short videos, we've taken a look at the baseline recommendations for the inspection of TLS encrypted web traffic, or SSL inspection as it's called inside the Zscaler admin UI. This is the final video, part 5, Operational Best Practices. Now that we've covered the why, what, and how you should inspect your traffic, including how to build your policy, let's talk about exemptions next. There are a few key rules for managing bypasses or exemptions for the SSL inspection. The first of these is that it's important to understand that SSL bypasses are a necessary part of SSL inspection, and that there are some circumstances in which SSL inspection will never be possible. The previously discussed technical limitations, such as issues with certificates or ciphers, or legal requirements to avoid inspecting certain categories, mean that you will never be able to inspect 100% of your traffic. There will be some traffic that needs to be bypassed. It's important to understand that SSL exemptions are not a catch-all solution to resolve any issue with the destination that doesn't load correctly or fails to load. With this in mind, here are some things you should watch out for. First, if you're going to create a bypass, you should first make sure that you actually need to create this. For applications or websites, the easiest way to do this is to simply raise a support ticket with the vendor or partner for that application and ask them whether or not their application or website does certificate pinning. The vendor or partner will be able to tell you yes or no. If it does, then you will need to create a bypass. If not, the issue probably lies elsewhere. Next, you should understand that it's important to inspect major domains and not bypass them entirely. These are highly visible on the internet, and therefore there's always a risk with them. Next, it's important to use FQDNs inside the bypass list, as IPs are not human readable and are bound to change. And finally, you should always build a bypass list that uses the most specific domains possible, i.e. corp.company.nl, instead of using a wildcard such as .company.nl. The reason for this is simple. If you exempt a wildcard, you exempt everything under that wildcard, which runs the risk of exempting traffic that you don't want to exempt. Something that's particularly important to note here is the risk of bypassing wildcards such as .amazonaws.com. Since AWS is a public cloud platform and anyone can pay to rent a storage bucket on there, if you bypass the entirety of AWS, you are opening yourself to the risk that a malicious actor might get an S3 bucket on AWS, host malware there, and distribute that malware to your users under an address that looks legitimate and is no longer being inspected. So be very careful with this and other public cloud services such as Azure. Next, here are some ways to make sure that your SSL bypass list stays at a manageable level. First, we recommend creating multiple specific URL categories to manage SSL exemptions, rather than creating a single super category that contains all SSL exemptions, which will quickly become difficult to manage. Second, it's important to keep the number of bypasses to a manageable level. The number 70 here is somewhat arbitrary, but the important thing to do is to make sure that you document any bypasses, understand why they were requested and why they were necessary, and that you understand their impact on your level of security and risk. Next, you should regularly review SSL bypasses to remove those that are not needed anymore. An easy way to do this is to use a SIEM if you have one configured. You can load your bypass list in your SIEM and look for a hit count. Any website that doesn't have a hit count or has a very low hit count can safely be removed from the bypass list as it's no longer being accessed by users. For large bypass lists, it might be easier to start from scratch, repiloting the entire SSL inspection process with a small group of users and a mostly empty bypass list. But this is only really recommended for extremely large bypass lists with multiple thousands of entries. As with the pilot process, the way to do this is to pick some test users from your IT organization, remove them from the existing bypass list, and add them to the new bypass list once you've added URLs to that bypass list. Finally, know that you can use the ZIA Web Insights logs to identify SSL errors. To do this, simply filter the logs to look for client SSL handshake failure aggregate count with a minimum value of 1. This will show you a list of transactions where the policy action is dropped due to failed client SSL handshake, and you can look at the client SSL handshake failure field to understand why the failure happened. Note that you can also filter these logs on client connection ciphers and client connection TLS version, as well as server connection ciphers and server connection TLS versions, to get a better understanding of which ciphers and TLS versions are in use. That's it for this series of videos. Thank you for watching.